Howdy guys, welcome to our chalk shortage lab. So we're trying to make an exact amount of chalk, and so that means we're going to use, we want an exact mass of our product, so that means we have to back calculate and we have to calculate the masses of the reactants. So you'll see two reactants here, and we already know that our chalk is calcium carbonate. So those two masses, those two reactants that I just showed you, one of them is going to have to be the limiting reactant. You're going to run out of one, and one of them is going to be excess. So you need to pick a limiting reactant. It doesn't exactly matter. Normally, I will pick the one that requires the highest mass, or the one that is the most expensive, because I just want to use a specific amount of that. And then the excess one, I can use excess of it. Okay, usually the least expensive or the one that has the highest mass. So that is how I think engineers will do that and try to design their experiments that way. So this is the general setup that we've got here. We've got our calcium carbonate and potassium carbonate and calcium chloride already set up. I'm not going to tell you the weights because everybody should be able to calculate the weights that you had. I just know that I will go ahead and tell you that calcium chloride was my limiting reactant that I'm picking this time. So just an FYI. You'll need filter paper and 2 beakers, and we are going to dissolve this in some water in the beaker, and then we're going to filter it through here. So let me show you how we fold our filter paper here. So what you do is you take your filter paper, and ideally you want to touch it as the least amount of times as possible. Adding oils can be a problem. So we will fold it first, and then we will fold it again. Now what you want to do then is you want to weigh this filter paper, and I'm going to weigh it right now, because we need to, we're going to have our product in this filter paper at the end, so we just want to be able to subtract it. So very good practice is just to always weigh the mass of your filter paper, even if you don't need it, even if you may or may not need it. So this one is being 0.78 grams. Did you hear me? 0.78 grams. So I'll write that one down. And I'll move on. So you take this folded piece of paper and then you just turn it into a cone like that, and so it fits just nice and neat in that funnel. And then I'll see if maybe you can see it. See if we can scoot this back. Now the best way to do that is then once it's in there, you go ahead and wet the filter paper so that it sticks to the sides, and it's good to go. It is ready to filter. Now another important thing is that we're going to catch all of our product, all that solid that's going to happen. We're going to catch it all in here, and all the stuff that comes out we don't care about. So you can add as much water to it as you want, and as much water to this as you really need to get it to dissolve. So the amount of water is one of those cases where you just don't have to worry about it. I'm going to go ahead and skip because you guys don't need to watch me dissolve stuff. Okay, we're back, and on the left we have the potassium carbonate, K2CO3, and on the right we have the calcium chloride. You can see on that calcium chloride it's still a little cloudy, and it should dissolve all the way. So if I heated it up and really made an effort to dissolve it, or gave it some more time, more stirring, it would probably dissolve, and that's what I probably should do, but I'm going to go ahead and move on. And so that would be a best lab practice, or maybe letting you know. Now, so if that's just a possible source of error, that's all well and good. Being able to recognize that is one thing, but being able to tell what will happen or how will it affect your results is another thing. And that's another thing you're going to have to look at. Is it going to make your results higher or lower? Or is it how much higher, how much lower? So that's also part of your error analysis. So try to get in that habit of thinking about if the results are going too high or too low. Now, I said earlier that the water needs also to be, it doesn't really matter what the amount of water that goes in there, and as you can tell, they have different amounts of water. But I had an oversight, and figured out that if I pour this beaker into this beaker, the beaker's not big enough, so I had to go grab a new one. We'll just go ahead and combine the two. That's not the best way you should pour, Mr. Russell. And then let's watch this one right here. So as soon as we get it, it should make a precipitate right away. Very, very nice. So we're going to go ahead and stir this one up and to make sure that the reaction goes to completion as far as possible. And then we're going to filter it. So I'll spare you all of the details of me stirring and filtering, but see you in a minute. Okay, and we're back. I've started to filter this, and another oversight of putting too much water in here is it's going to take forever for it to filter. So I'll be plugging at this all day, but let me just show you the correct way that we should pour. Now what you do is you take, let's use a shorter rod here. You take your stir rod and you put it over the lip of the beaker right here, and then you pour, and then that way the solution goes right down the rod. Okay, so that's what we're looking for, looking at that. Now another thing we're looking for is we're looking at when we have to rinse this. You know, we'll at the end, whenever we're done, we'll go ahead and try to rinse it, and we'll still pour that rinse down down the filter paper, because again, we don't really care about the water, we just care about the solid. Okay, so we're almost done with this. I'm shaking, stirring this last part up, and it's a good idea to try to cut down on all of that stuff that's stuck to the side by spraying that down, so that it runs down, and that will help really work. We're not super worried about precision or your error at this point. This is an exercise in stoichiometry, not exactly your lab techniques, but if you were doing your IA or something like that, you would really want to pay attention to things like that. So again, I'll try to spray down the stir rod, get all that white stuff off there, and I'm gonna try to wash this out, and it's gonna take a couple of rinses, and I'll still add it to the filter, and that's how that works. Alright guys, we are done filtering, and all I'm gonna do is use some tweezers to try to work this guy out of here, because it can be a little crazy. So when I get that, it should come right out, and there we go. I'll let it sit overnight, and I will let you know the results of this, and that's going to be it. We will go ahead and let's see. Yeah, this stuff right here, this is called the filtrate. This is the stuff that came through. This is all water. Ideally, we would run it through the filter again, just to make sure we caught every little thing. But we're just going to go ahead and dump that one down the sink, because it's just water and potassium chloride, which is just salt. So we saw that the mass of the filter paper was 0.78 grams, and so the mass of, I'm flashing forward in the future, the mass of the chalk and the filter paper is going to be 2.13. So just want to let you guys know. Have a great day.